Our lesson on 7.6 part 2 is going to continue our discussion on how to solve equations that have square roots in them. Except today, if we were to simply square both sides like we're used to doing, we'd end up with quadratics. Now sometimes algebraic methods are not the quickest way, and I'm going to show you another method for solving these problems rather than algebraically, and that's going to be through graphing. So our first example, and the directions on your set of notes says, use your graphing utility to solve each equation. Sketch a graph of the intersection of the two functions, and they want to give you a little warning here that some of the problems may have more than one solution, and in fact some of the problems may have no solution, so we have to be extra careful. So I'm going to pull up my calculator, and what I'm going to do is I'm going to go to y equals, and in y1 I'm going to type the left hand side of the equation. So for number 1, it's the square root of 12 minus x in our case. Can't use n on my calculator, so I use the x. Now you can close the parenthesis, or if you forgot, it's not a big deal for this problem. Now in y2, I want you to write the other side of the equation, which is just simply a variable x, or n, in the way they wrote it. Now I should be in my standard window, and if you aren't in your standard window, hit zoom and then 6, and you should see something that looks like that. Now your task is to go to your, on your paper, I want you to kind of sketch that for me. Now it's going to be a little difficult for me to sketch it, so hang with me. Whoop, that's extra bad. So it looks something like this. Now the solution to this equation would be where these 2 points intersect. So your job is to find that point of intersection on your calculator. And the way we do that is we go to Second, Trace, and we choose what's called intersect. And it's going to say first curve question mark. Well, you say yes by hitting the enter. And then second curve, hit enter one more time. And then for guess, just hit enter a third time. So basically we did second trace and then enter, enter, enter. Now you're going to notice it gives you both an x and a y value. For these problems, we really just want to know the x value because that's the variable we used in the equation. So the answer here was x equals 3. And trust me, that's a lot quicker than doing the quadratic method, because by squaring both sides, and I can do that for you real fast if you don't believe me, if I were to square both sides of this equation, I'd end up with 12 minus n equals n squared, and then we'd have to solve this quadratic through one of our methods. So I would pull everything to one side, set it equal to 0, and then you'd have to go ahead and either factor it or use quadratic formula or complete the square. So we'd get n plus 4 and n minus 3. Now again, I'm going very quickly through this because I have a lot of practice factoring. Maybe you don't like factoring so much. And we get our two answers of n equals -4 and n equals 3. Well, turns out that when you plug in the -4 into the original equation, this is what we call an extraneous solution. Now the 3 still worked, and actually I should go back here. Instead of calling this x, I should say that this means n equals 3. But notice the amount of work that is involved with the quadratic algebraic method. You have to square it, you have to know one of the methods for solving the quadratic, you gotta factor it, you gotta solve it, and then you have to go back and check both your answers to see if either of them are extraneous. When you graph using, when you solve this using the graphing technique, you'll never find any extraneous solutions because the graph won't ever show it. Alright, let's move on. Let's try our next example. And I'm just going to stick to the graphing method because that seems like a good idea. So on the y1, we're going to write the left-hand side of the equation, which is the square root, the square root of -24 plus 10x and then the right hand side, or y2, is just going to be x again. So we're going to hit graph. Now this time I want you to sketch it on your paper. I would like you to go ahead and do that. And again, I'm not doing a very good job, but it kind of looks like this. Whoops. Again, I did a terrible job. Now back to your graph. It looks like this line crosses this curve two places, like maybe right here and maybe right here. And if you weren't sure, you could zoom in or adjust your window to get a better picture. But I'm here to tell you there are two answers to this problem. So we're going to do it the same way. We're going to go to second trace, and we're going to pull up intersect. And then when it says first curve, question mark, you're going to notice that it says x equals 0, but there's no y value. That's because your calculator hasn't actually found the first curve yet. So I need you to hit the right arrow for a couple of times here until it actually lands somewhere on that curve. There we go. So it was actually off of the curve for a minute. Now once you have a whole ordered pair, hit enter. Second curve looks like we're good, so I'm just going to hit enter. And then guess, hit enter one last time. And the first intersection point we find is at 4, 4. Now, that means one of our solutions is x equals 4. Let's go back to our calculator. And we're going to find the second intersection point by using the same set of steps here. We're going to go to intersect. It already is on the first curve, so just hit enter. It's on the second curve, hit enter. But this time, before you hit enter the third time for guess, I need you to scroll so that you're a little bit closer to where you think the other intersection point is. Otherwise, it's going to keep finding that same first intersection point. Once you're kind of more off to the right-hand side, hit enter, and it's going to give you 6, 6. Which means we have another answer at x equals 6. So both of these come out to be true answers, so you need to have both of them. I'm just going to jot down our steps real quick for graphing, or finding solutions by graphing. So our first step was to put the left-hand side into y1 and the right-hand side into y2. And then once you graphed it, we went to second trace, which is the calc menu. We chose number 5, which was intersect. And then basically, in most cases, we just hit enter, enter, enter. So enter 3 times. And it gave you your answer. Now in this last problem, we did find out that we had to kind of scroll around a little bit in order to either get on the curve or to get the appropriate intersection point. Alright, our next problem that I'm going to type in is square root of 65 minus 7k square root of 65 minus 7k, so I'm going to use 7x. Oops, I forgot the minus. And then I'm going to delete the rest. And again, you don't have to close the parentheses, but you can. Now on the right hand side, we're going to have k minus 11, so I'm going to type x minus 11. And then I'm going to hit graph. Now, I don't know if you can tell this, but the curve right here stops, and then here is the line. And it's pretty easy to see, even in this screen, that these curves are never going to intersect. Well, since they never intersect, that means there is no solution. So that's what you're going to write down. No solution, because they never intersect. And if you tried, whoops, if you tried to find an intersection point using your intersect tool, it just would give you an error and it would say, yeah, there is no intersection point. Okay, the next problem, we're going to type in the left hand side into y1, which is just x in our case. And then the right hand side, we're going to type the square root of 3x minus 2. Now here you have to make sure to close the parentheses so you stop the square root, because that next plus 2 is outside, whoops, plus 2. That plus 2 is outside of the radical. Okay, this definitely intersects, and it looks like it only intersects one time. So second trace, choose intersect, and then enter. Now the second curve, it's not on the curve yet. Notice how the y is empty? So you're going to have to scroll to the right until you actually find the curve, and there we are. So we get an answer of 6. So k equals 6. Alright. Now, I didn't draw the curves for 3 or 4 just because I'm trying to save a little time and space. But you should be drawing the curves. Okay, let's try 5 and 6. And again, I want you to draw the curves, a little sketch, to show me that you actually did do this. But I'm not going to draw the sketch of the curves. So for number 5, we have x on the left-hand side. And then we have, let's just clear that out, 3 plus the square root of x minus 1. Again, you don't have to close the parenthesis here because the problem stopped. But let's hit graph. And I'm going to see one intersection point, and to make my calculator find it, I'm going to use the trace function. So second trace, I'm going to choose intersect, and then first curve, enter. Second curve, it looks like we're not on the curve yet, so you need to press your right arrow, which this is what I mean by right arrow, a few times until it pops up on the curve, and then enter a third time. So your answer here is 5. And then we're going to find 2 answers, I believe, on number 6, but let's verify that with our calculator. So go to y equals, type in this time x minus 5 into the left-hand side, or for y1, and then let me clear that out. We have the square root of 5b, so for us it's 5x minus 25, and then when I graph it, I don't know how easy it is for you to see that there are 2 intersection points. If you need a better window, go ahead and find one. So I'm going to find the bottom intersection point first. Okay, first curve. Now second curve, I'm not there yet, so I have to hit my right arrow until it shows up on my second curve. Any day now. There he is. Okay. Enter, and then enter. So it looks like that guy has an intersection at x equals 10. So let's write that down before I forget it. Oh, I should write b, huh? b equals 10. And then let's go find the second intersection point. Now remember, when I go through all this, second trace, intersect, enter, enter. I just need to make sure that I'm closer to the other intersection point before I hit enter a third time. Whoops. I think that was the first one I found, wasn't it? Never mind, let's try that again. Second trace. Hello. Number 5. Enter, enter. No, I was going to the wrong one last time. So this time, scroll so you were closer to the bottom intersection point. I found the top one first by accident. Okay, try again. Second trace. Intersect. Enter. Enter. My goodness. Okay. Second trace. Intersect. Enter. Oh, pardon my calculator. Oopsies, hello. Okay, I'm not sure why this calculator is not working for me, but the other answer is actually going to be b equals 5, and it should be finding it, and I'm not sure why it's not. I don't really know. If you didn't believe me, if we think about plugging in a 5, it's going to work. And I think when I tried this on my calculator, my normal calculator at home, it worked just fine. So, not sure why it's giving me trouble. But think about it, guys. 5 minus 5 is 0. And if you plug in a 5 over here, 5 times 5 is 25. Minus 25 is 0. Square root of 0 is 0. So for some reason, my computer simulator calculator does not like to do that problem. I have no idea. So apologies, but those are the 2 answers. B equals 10 and B equals 5, and you have to find me both of them. Alright, that concludes the lesson on 7.6 part 2. Your homework on this is just on the back of your notes, so please continue. Make sure you draw the graph. Sketch a graph. It doesn't have to look real pretty, just it basically is proving to me that you didn't just copy off of a friend, so please do that.